Hello, class. This is a recorded lecture starting in chapter 5 now, and we're going to introduce this idea of polar coordinates. So again, what makes Trig, I think, very challenging is these ideas of introducing these new math concepts that you've never seen before. And so we've been living in the world of the Cartesian coordinate plane, where the horizontal axis is the x variable and the vertical axis is the y variable. And we're going to introduce a transformation from one plane to a new plane, which is called polar coordinates. And it's based on trigonometry, where instead of having an x variable and a y variable, you're going to have a r variable, which is really a radius, and a angle variable, which we're calling theta. And so what we're going to do is define that for you and kind of show you um, the benefits of it with regards to this transformation. And so here's what we're going to do in section 5.1. Define it, show you the relationship between the two, and then show you the benefit of a polar equation with regards to the difference between rectangular and polar and its benefits. So here's the definition. And again, we're starting at this idea of an origin. And you can see it looks like a right triangle idea. And so the idea is that you start at the origin. And the distance from the origin to this point P is given by two parameters. The first is R, and that's the distance. And the second is theta. And theta starts again at the positive old x-axis, right? And as you go counterclockwise, theta becomes a positive number. And so we talk about this idea of point P. So it's going to be defined by two numbers. And so when we pull up the whiteboard, let's see here, we're going to define it as two numbers. And again, it's defined as R and theta, just like an analogous, we defined Cartesian coordinates of x and y. And so the idea is that if you took a point where we call P here, right? And this is R, and this would be theta. And so this distance here is R, and the distance angle-wise from positive x-axis to that line segment is theta. And again, counterclockwise is positive, and clockwise is negative. So what is the relationship with regards to these calculations, right? And so let me get this back up. And so the idea is the first we need to find this distance. And the second thing we need to do is to find the angle. So we're going to have a relationship between the Cartesian coordinate system and the polar coordinate system. But before we do that, let's just start to get a little bit familiar on what we mean by these two numbers. And so if you look at the first one, and I'm just going to use let me see if I can make this a little bit bigger, right? There we go. And so here's our first point. R equals 1, and then 3 pi over 4 for our angle. So if R equals 1, we would take a distance of 1, and we would have an angle of 3 pi over 4, which is 135 degrees, I believe. Here on this one, we have R equals 3, and now we're going negative, right? That's negative 30 degrees. And so in this case, we're going clockwise in this case. If you go 3 pi, you go around once, and then you end up back at the old positive x-axis, right? And so you could see that point would be the point x equals 3. This one is quite tricky because now we have a negative r. Well, how does that work? Well, here's the way I'd like to think about the negative r's. And let me pull up the whiteboard. So the way I like to think about the negative r's is, say, like we do this one. And so we have -4 and pi over 4, which is, what is that, 45 degrees, right? So this would be pi over 4, and say like this is +4. And so what the minus does is gives it, if you want to think about it, this is how it works in my head, 180-degree phase shift. So you take this thing and you flip it around the origin, and so the -4 ends up over here. And so this would be -4 and pi over 4. Another way to think about this is that the 4 and pi over 4 and the relationship between -4 and pi over 4 is 180 degrees, right? So if you think about it, if I add pi to this, right, and you do +4, and then you do 5 pi over 4, right? You add pi to pi over 4, you see it flips around. Here's pi, and this would be 4 pi over 4, and then 5 pi over 4 does that. So the way to think about this negative is what I would think about it as a 180-degree phase shift from the original R value. I know I'm throwing a lot out at you with regards to this. And so one of the things that I did do is in our Brightspace site, I uploaded what's called polar graph paper. And you could see how it's oriented. Well, here they give you the X and Y, but that's not what we're dealing with, right? So if these concentric circles, this would be r equals 1. The next circle would be r equals 2. The next circle would be r equals 3. And so you'd have that delineation for r. And then this is 0 degrees. The dotted line would be pi over 4 or 45 degrees, 90 degrees, 135, and so on and so forth. So I've uploaded this, and if we were together, I would print you out a couple copies so you could play with it when you're doing plotting of points with regards to those graphs. But if you had to do it by hand, I'll show you what I do. So here's what I do. Let me clear this here. And so if you're generating these by hand, and so sometimes it's nice I have a different color, so I'll just generate the circles. And you do the best you can. And so that's what the circles would look like if you're trying to do it by hand. And this would be r equals 1, r equals 2, and r equals 3. So that's the distance. So I think some of you are probably already realizing the relationship between r and x and y and theta and x and y. And so let me define that for you here. And so if we take a look at our definition, you could see we're back to the right triangle. That's why I said, if you think about the unit circle and the right triangle approach, and you got a good foundation of that, I think you'll be able to transform in your mind the difference between polar and rectangular, right? What is r? It's the hypotenuse. And what is theta? Theta is the angle from, the positive x-axis to the hypotenuse, right? With regards to the unit circle idea. So when you have the relationship between here we go. Sorry about that. I couldn't find the right slide. So here on slide 12, you find the relationship. So if you want to go from polar to rectangular or vice versa, we have it right here. And you could see that r squared equals x squared plus y squared, right? Pythagorean's theorem. And then tangent, right? If we go back to our graph here, tangent would be y over x, right? And so to find that, that would be the angle. And so if you know y over x, you just do tan inverse to find theta. And then if you wanted to go from polar, right? If you have r and theta and you want to find x and y, you could see from our triangle here that the x value would be r cosine of theta, and the y value would be r times sine of theta. So again, this idea of unit circle right triangle approach to understand is really important for this foundation. And so, like I said, what makes this difficult is this is the first time that you are introduced to something called a transformation. And what do we mean by a transformation? Is that we are taking a coordinate system and moving it to a different coordinate system by the relationship of those equations. So to end the first part of this recorded lecture, let's walk through a couple examples of calculations. So let me stick up here in red. Here's our relationship, right? R squared equals x squared plus y squared. And tan of theta equals y over x. Or if you want to go the other way, x equals r cosine of theta, and y equals r sine of theta. So say like I give you let's do one example here. Say like you're given a polar point of 4 and 2 pi over 3. So if you think about that, all right, where would that be? Well, 4 would be 4 units from the origin. And so if I draw my concentric circles, 2, 3, 4. So it would be on there. And then what is 2 pi over 3? So 3 goes into what, 180, 60 times, right? And so 60 times 2 is 120. So if I put this dot in here, and let me put it in blue, it would be 1, 2, 3, 4, and the angle would be 120 degrees. So say like it'd be about right here, right? And so if you think about it, that angle there would be 2 pi over 3. And the fourth concentric circle, that would be a distance from the origin of 4. So this distance here to here would be the number 4. So if you think about it, when you do this calculation, what's going to happen? Well, if you look at where the x and y numbers are, right, what would be x and y? And let's put that in green. Well, the one thing that you could look at is we're in what? We're in quadrant 2. So what happens? The y value is going to be positive and the x value is going to be negative. So let's do the calculation. So again, with our equation, let's plug in 4, and then r is 4, I don't need an r there. And then you end up with cosine of 2 pi over 3. And so you get out your calculator or the sheet, right? But you could see that if you do that calculation, you're going to get x equals -2. And it should feel right because you know you're in quadrant 2. And then y would equal or sine of 2 pi over 3. You could get out your calculator, be 100% okay, or you could get out your little table, and this is one of our angles that we know would look like this. And so this would be 2 square root of 3. And so the x value is -2, and the y value is 2 square root of 3. So hopefully by this visual and the calculation, you can kind of see the relationship, right? So when you're in the first quadrant, x and y are going to be positive, and as you continue around all 4 quadrants, things will change. And when you're in quadrant 3, both of them will be negative. So this is kind of weird, but I do want to point this out, is that the equations relating to polar and rectangulars do not uniquely determine r or theta, especially because theta could be, when you go around 2 pi, you end up back at the same place. It's a little bit different with regards to that. But when we use these equations to find coordinates of a point, we must be careful that the values we choose for r and theta gives us the point in the correct quadrant. And so that's important, and it's all based on theta, right? So make sure that when you're looking at the xy value and you're trying to find where you're at, make sure your theta gets you to the right quadrant. So that'll end the first of, I think, probably 2 recorded lectures for section 5.1, which is the introduction of polar coordinate systems.